Hello everyone. This is your Weekly Essentials number 2 video. Today we are looking at parts of an expression and function notation. Alright, so on number 1, we need to simplify the expression and then we are going to list out the parts of that expression. So I have 3x plus 4 plus 5x minus 6. So I want to see if there's any like terms that I can combine. So I see 3x, I see 5x. I know that's going to combine to give me 8x. And then I see 4 and negative 6. So 4 minus 6 is negative 2. So my simplified expression is going to be 8x minus 2. Okay, so then I want to go through and do my terms. If you remember terms, the way that we can remember what a term is, terms are usually separated by plus and minus signs. Okay, so if I look, I've got 8x minus 2. So there's really two parts here. I've got 8x and I have minus 2. Okay, factors. So factors, you want to think about multiplication. So I always say go back to the terms and see is there anything that's being multiplied up there. Well, within the terms, you see 8x. Well, there's no sign in between there. That means that the 8 and the x are being multiplied together. So your factors are 8x. Coefficients are numbers that are found in front of variables. So the number found in front of my variable would be the 8. And then your constant is going to be the number that has no variable attached to it. So if I have 8x minus 2, the minus 2 is my constant. Okay. So number 2, I have 3x minus 0.25 times 3x. So it says simplified expression. I see 3x and 3x. I'm going to have to multiply. So can I multiply this negative 0.25 times 3x? Will give us 3x minus 0.75x. Okay, well then you can combine like terms. 3x minus 0.75x is going to give you 2.25x. So this time there's one part. I have one term. There's only one piece. 2.25x. That's my only term. My factors are, is anything being multiplied? Well, that's 2.25 times x. So the factors are 2.25 and x. Coefficients are numbers found in front of your variable. So if we look in front of the variable, 2.25. And your constants are numbers that don't have variables. Well, there's nothing there, so there's no constant. Okay, so hopefully you guys remember. So terms are separated by your plus minus signs. Factors are usually found where some variables being multiplied by another number in the cases that we've seen. Coefficients are numbers found in front of variables, and constants are the numbers that don't have variables attached to them. Okay, so number 3, evaluate f of negative 2 for f of x equals negative 3 x squared plus x minus 5. Well, if we look at this right here, I see that this x needs to be replaced with negative 2. So if I'm replacing x with negative 2, that just means anywhere I see an x, I'm putting a negative 2. Okay, and I'm going to be careful with parentheses there because negative 2 squared, you guys, when you put this in your calculator, you have to be very careful because if you plug that into your calculator without parentheses, it's going to give you negative 4. And what do you know, because you guys are so smart, you know a negative squared is what? A negative times a negative is a positive. So this right here, this negative 3, this negative 2 squared is actually going to become a positive 4. You shouldn't get a negative 4 there. Minus 2 minus 5. I'm going one piece at a time. Well, then I have this negative 3 times 4. Negative 3 times 4, you know, is negative 12, minus 2, minus 5. Well, I could do all of that at once. Negative 12 minus 2 minus 5 is going to give you negative 19. So f of negative 2 equals negative 19. What if we said, hey, can you give that to me as an ordered pair? Do you guys remember what that would be? If the input was negative 2, it means when you input negative 2, it's spitting out a negative 19, right? So if, and this isn't on your paper, but if we asked you to write this as an ordered pair, the x value of the ordered pair would be negative 2 because that's your input, the independent variable. What is the output? Negative 19, the y value. So you input the x, it spits out the y, right? So the ordered pair there is negative 219. Okay. Number 4. It says f of x equals negative 2x plus 7. Find the range given the domain. If you know domain, we know domain is x. And if we know, and we're trying to find range, the range is your y value, domain are the x's. So if I have this function and I have these x values, the way you find a y, if you know an x, the way you find a y is by plugging it in. The domain is the input, the range is the output. So I'm just going to start doing some evaluating. I need to evaluate f of negative 2. I need to evaluate f of negative 1, f of 0, f of 1, and f of 2. So every single one of those x values up here, I need to plug all of them into that equation, and it's going to give me my y value for that particular x. So negative 2 times negative 2 plus 7. Okay, negative 2 times negative 2 is 4. 4 plus 7 is 11. Then I have negative 2 times negative 1 plus 7. Negative 2 times negative 1, a negative times a negative is a positive, so positive 2 plus 7 is 9. Now we need to plug in a 0. 2 times 0 plus 7. Well, 2 times 0 is 0. 0 plus 7 is 7. Plug in a 1. 2 times 1 plus 7. 2 times 1 is 2. 2 plus 7 is 9. Then I plug in a 2. Oh, wait a minute. We need to go back. Go back. That's why I messed up. That's a negative 2. That's not going to change that. Negative 2 times 0 is 0 still. Negative 2 times 1 plus 7. I couldn't figure out there. Negative 2 times positive 1 is negative 2. Negative 2 plus 7 is 5. That's right. There we go. Sorry, guys. Then negative 2 times 2 plus 7. Negative 2 times 2 is negative 4, and negative 4 plus 7 is 3. Okay, so then I come back and I look, and I've got 11, 9, 7, 5, and 3. All of these are my y values. Okay, so when it asks for the range is all of the y values. If I had 5 values for my domain, I should have 5 values for my range. Every input has an output, right? So my range then, remember we've always said to write your numbers in order from least to greatest. So I'm going to start here at the bottom. 3, 5, 7, 9, and 11. And there's your range. Okay, so domain is x, range is y. Alrighty, so now number 5. Given f of x equals 2x minus 5, okay, I have this equation, find x. That gives this away. It tells you what you're doing. What are you looking for here? It says find x if f of x is 15. Okay, basically f of x, because of we know function notation, do you guys remember f of x is the same thing as y. So whenever you see f of x, you could think y. Well, it's, in other words, it's saying find x if y is 15. All right, so if we think of x as being an input and y as being an output, it's saying find the input that gives you the output of 15. Okay, the output's what you're equal to. Okay, so that's another way to think of that if you guys struggle with this. Well, Okay, so this says f of x equals 15. That means that anywhere I see an f of x, I could write a 15. So I go back to this original equation right here. Do you see an f of x? I do, right there. So this f of x is equal to 15, so I could just replace f of x with 15 equals 2x minus 5. And now look at what happens. It said find x. We now have the equation set up so that we can solve it for x. We use inverse operations. So if I have 2x minus 5, I need to undo the subtraction first. So we add 5 to both sides. 20 equals 2x. This 2x, we understand, we know that the operation there is multiplication. To undo multiplication, we divide. So we're going to divide by 2. 20 divided by 2 is 10. So I end up with x equals 10. Okay? So if you wanted to, you could go back and check, couldn't you? If I am correct, then this means that when x is 10, the y should be 15, meaning if I input 10, the output should be 15. So I'm going to just go back and I'm going to check it just to see. All right, so this would be f of 10 equals 2 times 10 minus 5. Well, 2 times 10 is 20. 20 minus 5 is 15. Did we get it right? We did. So again, the ordered pair here is if x is 10 and y is 15, the ordered pair is 10, 15, if it had you do that. Okay, so we have another one like that on number 6. Given f of x equals x divided by 2 plus 10, find x if f of x is 8. Okay, f of x. F of x equals 8, 8 equals f of x. They're interchangeable. They can replace each other. So I go back to this original equation and I see an f of x. Well, hey, I know f of x is 8. So I can replace f of x with an 8 equals x over 2 plus 10. Okay, so then we have to do inverse operations. Okay, so I have x divided by 2 plus 10. What needs to go away first? That's right, the 10. So if it's plus 10, you subtract 10. 8 minus 10 is negative 2 equals x divided by 2. Well, if I need to undo divide by 2, I'm going to multiply both sides by 2. Okay, so 2 times negative 2 is 4. And then my 2's cancel out and I get x. So I get for my final answer, x equals 4. And if I wanted to, I could go back and check. Basically what I'm trying to check to see is if I put a 4 in there, am I going negative 4? Look at there. 2 times negative 2 is negative 4. So my answer should actually be negative 4, not positive 4. Got to pay attention to details. I'm not doing a good job of that, am I? Negative 4. So I'm checking, I'm plugging in a negative 4. So I get negative 4 over 2 plus 10. Negative 4 divided by 2 is negative 2 plus 10, and negative 2 plus 10 is 8. Check. We got it. So the ordered pair here, if it asked you, would be negative 4, comma, 8. All right, so number 7, is the following relation a function and why? So I don't know if you guys remember or not, but when we talked about functions, so a relation is a function if and only if there are no repeating x values, right? Every input has one output, okay? So if I look, I've got negative 8, 2, negative 6, 1, negative 2, 2, 0, 3, 0, 7, 4, 10. I have a problem. Hopefully you guys noticed, whoa, wait a minute. There's 2 values of x that equal 0. So that means that I have a point at 0, 3 and a point at 0, 7, and no, this is not a function. There are repeating x's, right? So no, this is not a function. And let's just take this one step further. If I were to take these points and I were to plot them, it would look something like -8, 2, maybe somewhere over here. -6, 1, maybe somewhere right here. -2, 2, maybe up here. 0, 3 would be here. 0, 7 would be here. And 4, 10 would be somewhere up here. So if I were to connect these points, and maybe I should use a different color, so you see, if I connected these points right here, I've got this red graph. Do you guys remember when we did this, we said, okay, if I draw a vertical line and I move this vertical line, I have to pass the vertical line test, right? Well, when I come right here to these 2 points, 0, 3 and 0, 7, I don't pass the vertical line test there. Therefore, this relation cannot be a function because there's repeating x values. Okay, and the last one, number 8, is this a function? So I'm going to check 1 goes to D, 2 goes to B, 3 goes to C, and 4 goes to C. Okay, yes, this is a function. There are no repeating x values. Remember, in a function, you can have repeating y values. You just cannot have repeating x values, okay? So let me give you an example really quickly with a graph. If I have this graph right here, if it looks something like this, I may have this point here, if this were at 0. This would be the point 2, 4, and this would be the point -2, 4. Okay? These 2 points have the same y value, but they have different x's. And if I draw my vertical line again, like we just did a second ago, I notice this purple graph passes the vertical line test everywhere. So you can have repeating y's, you just cannot have repeating x values. All right, guys, that's it. Great job.